Okay. Now, if we look at the graph of our function and try to estimate the x-intercepts, it's not hard to estimate the x-intercepts. Now, I've kind of obscured some of the marks on my graph, but here's 4, here's 5, and here's 3. Okay? And the x-intercepts, if you've drawn this graph in any way carefully, are going to be a little to the right of, did I say 4? Here's 4, here's 5, a little to the right of 5, and here's 4, here's 3, a little to the left of 3. What about the y-intercepts? Well, the y-intercepts of these two graphs are easy, but the y-intercept of either of these graphs is going to be way up there, way off of the picture. Okay, you don't even want to try to draw that. You note the y-intercept is going to be some positive number, and it's going to be quite a bit bigger than any of the y values we have in this table. And right there's 4, here's another 4. Biggest y value we've represented here would be 8. It's going to be much higher than that. So we do it algebraically. And then we check and see if it's kind of way up there. Okay? We know that the y-intercept occurs when? When x equals 0. Because the y-axis is characterized by the fact that everywhere on the axis the x-coordinate is 0. So x equals 0 at the y-intercept, so the y-intercept is at y equals what we get when we replace x by 0. 2 times 0 minus 4, quantity squared, minus 3. You can work out the arithmetic. I believe it's 29. Let me know if I made a mistake, but I'm pretty confident of that one. Okay. So there's our y-intercept. Now what about our x-intercepts? That's a little bit more involved because the x-intercept occurs when y equals 0, so that our y is the 2 times quantity x minus 4 squared minus 3. That's got to equal 0. And there are a few little potential stumbling blocks in figuring out the value of x, although it's actually pretty simple once you see what's going on. So from here, how do we solve? How do we begin solving this? Well, we can add 3 to both sides. We want to isolate x on this side, right? Okay? We don't want that 3 there. We want that, we want that 3 away from this side. We can accomplish that by adding 3 to both sides, and we get this. Now, we can't do anything about that 4 because it's part of what's squared, but we got the 2 here, and we can divide both sides by 2, or multiply both sides by 1/2, whichever way you want to think about it. And we get x minus 4 squared is 3/2. Okay, now, this is where people will often have a little bit of trouble. Okay, we've got x minus 4 squared equals 3/2. What can we do with that? Okay, well, some people say take the square root of both sides. We've taken the square root of both sides. Doesn't quite work, although it's not a bad idea. And if you take the square root of both sides, you will get something that would give you a solution, but it turns out there are actually 2 solutions. So let's think about what it means for something squared to be equal to something else. Now, over here I digressed. Said, okay, let's think. We're up to this point where something squared equals some number. Well, if aardvark squared is 16, then what is aardvark? Think that through yourself. Okay, well, clearly, if you square 4, you get 16. So aardvark could be square root of 16. That would be a good solution. But aardvark could also be negative square root of 16. And why is that? Well, first of all, square root of 16 is 4. Obviously, if aardvark is 4, aardvark squared is 16. But also, if aardvark is negative 4, aardvark squared is still negative 4 times negative 4 is 16. Okay? So, 4 squared is 16. If you square negative 4, you get 16. So aardvark could be plus or minus the square root of 16 plus or minus 4. Well, by analogy with what we've done here, if x minus 4 squared is 3/2, well, x minus 4 is our aardvark. Our aardvark's whatever is being squared, okay? So our x minus 4 is plus or minus the square root of 3/2. Okay, so in the solution to something squared, to aardvark squared equals some number, is always aardvark equals plus or minus the square root of that number. In this case, again, our aardvark is x minus 4 because that's what we're squaring to get 3/2. So our aardvark, our x minus 4, has to be plus or minus the square root of 3/2. You can just remember that as a rule, as long as you remember it, but you should also understand it, that you're squaring something, and it doesn't matter whether that something is positive or negative, you are going to get a positive result. Okay, anyhow, then, and this is so because if you square the square root of 3/2, you get 3/2. So if x minus 4 is 3/2, x minus 4 square root of 3/2, x minus 4 squared is 3/2. Also, if x minus 4 is negative square root of 3/2, well, if you square the square root of, if you square negative square root of 3/2, and I think my square root is there, but the board is awful smudged, so let's make sure we can see it. Square negative square root of 3/2, you still get 3/2. Convince yourself of that. Convince yourself that if you have something squared equal to something else, then the something you're squaring is plus or minus the square root of that something else. Okay, well, once we see that x minus 4 could be 3/2, or x minus 4 could be negative 3/2. And now it's very easy to solve for x. Okay, if x minus 4 is 3/2, then add 4 to both sides, you get x equals 4 plus the square root of 3/2, and I haven't been saying square root, something loose in there today. And if x minus 4 is negative square root of 3/2, then adding 4 to both sides gives x equals 4 minus square root of 3/2. So those are solutions for x. This always happens when you have something squared equal something else. You always break it down into two different equations, just like you would with an absolute value. Okay, it's not an absolute value. It does this for a different reason, but it becomes two equations. You just have to know that. You'll see that in the examples in your book. You see me do it in other instances too. Okay, so we have these two equations that give you these two solutions for x. Now let's just check that with our observation that this x-intercept is a little more than 5, and this one is a little less than 3. Okay? Now, square root of 3/2, just the two significant figures, is 1.2. Okay? I'll just say, I know that 12 squared is 144, 13 squared is 169, so 1.2 squared is 1.44, and 1.3 squared is 1.69. 3/2 is 1.5, which is closer, much closer, to 1.44 than it is to 1.69. So I know that the square root of 3/2 is closer to 1.2 than it is to 1.3. I kind of think it comes out between 1.22 and 1.23, and I kind of think it probably rounds off to 1.23, but I haven't checked that out, and I haven't bothered to think hard enough to do that. It's not that hard to tell. You don't have to go to your calculator, which is kind of fun. Well, anyhow. Okay, so square root of 3/2 is close to 1.2, close enough, so that 4 plus the square root of 3/2 is 5.2, and 4 minus the square root of 3/2, of course that'd be 4 minus about 1.2, approximately 2.8. Well, we said that the x-intercept here should be a little more than 5, that's right, and that the y-intercept should be a little less than 3, and 2.8 is a little less than 3. So it checks out. Now there's another way we could have solved for the x and y-intercepts, so I'll run through that next.